Propane as well as methoxymethane, although they have same molecular mass as well as comparable molecular mass, this is due to the presence of intermolecular hydrogen bonding. As electron density increases, the polarity of the OH group decreases, the stability is decreases, as well as acidic strength also decreases. In the presence of chromic trioxide or chromic anhydride, it gets oxidized to ketone or C double bond O R dash. Hello my dear students, I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Welcome to third session of chapter Alcohols, Phenols and Ethers. Third session of chapters Alcohol, Phenols and Ethers. In the previous session, that is in the second session, I discussed about methods of preparation of alcohols from alkenes, from carbonyl compounds, from Grignard reagents. Last class, I discussed about how alcohols are prepared from alkenes and how alcohols are prepared from carbonyl compounds, that is from aldehydes, ketones and carboxylic acid. Third one, how alcohols are prepared from Grignard reagent. In this class, that is in the third session, I am going to discuss about the physical and chemical properties of alcohols. Physical and chemical properties of alcohol. Let us consider the first one, physical properties of alcohol. Alcohol consists of two parts. One is the functional group, OH group. Functional group of alcohol is OH. Next R is alkyl or aralkyl group. Alkyl or aralkyl group. Alkyl or aralkyl or vinyl group. The properties of alcohols are due to the presence of OH group. The properties of alcohols are due to the presence of OH group. The alkyl aryl group, they modify the properties like boiling points as well as what? Solubility. Therefore, alcohol, what's the general formula of alcohol? ROH. Alcohol consists of two parts. One is functional group OH, another one is capital R, that is alkyl, aralkyl or vinyl group. OH group is responsible for the properties of alcohol. Alkyl, aryl and vinyl group are modify the properties. Under these properties, we are going to deal with boiling points as well as what? Solubility. Boiling point and solubility. First one, let us consider boiling point. The boiling points of alcohol as increases with increase in the number of carbon atom. The boiling point of alcohol is directly proportional to number of carbon atoms. For example, when you consider methanol, ethanol, propanol, butanol, butanol has highest boiling point because it contains 4 carbon atom. As the number of carbon atom increases, the boiling point also increases. Second point, the boiling point of alcohol depends upon branching. Already I explained in the first chapter of organic chemistry, haloalkanes and haloarenes. As branching increases, the boiling point decreases because of the decrease in the van der Waals force of attraction. Decrease in the van der Waals force of attraction, because as surface area decreases, the van der Waals force of attraction also decreases. Therefore, the boiling point is inversely proportional to branching. Boiling point is inversely proportional to branching. Therefore, the boiling point of alcohol depends upon two factors. First one, number of carbon atoms. Second one, branching. As the number of carbon atoms increases, the boiling point of alcohol also increases. Second point, as branching increases, the boiling point decreases. Why? As branching increases, the surface area decreases as well as the van der Waals force also decreases. Next, in alcohols, the hydrogen atom of the OH group is bonded to electronegative oxygen atom. A hydrogen atom of OH group attached to most electronegative oxygen atom. Therefore, it is capable of forming intermolecular hydrogen bonding. Observe here, alcohols having a capacity to form intermolecular hydrogen bonding. This shows the formation of intermolecular hydrogen bonding in alcohol. Therefore, alcohols containing intermolecular hydrogen bonding. Because of this intermolecular hydrogen bonding, alcohols have higher boiling point than that of corresponding compounds, hydrocarbons, ethers and haloalkanes and haloarenes of comparable molecular mass. The boiling point of alcohol is high due to the presence of intermolecular hydrogen bonding. Due to the presence of intermolecular hydrogen bonding, alcohols have high boiling point than corresponding other classes of compounds like haloalkanes, haloarenes, hydrocarbons, ethers, etc. For example, when you consider, observe here, I had taken three compounds. First one ethanol, second one methoxymethane, third one is propane. Methoxymethane is CH3OCH3, it's a ether. Propane, CH3CH2CH3. Here I will take an alcohol ethanol whose molecular mass is 46. Here also molecular mass is 46. Although their molecular masses are same, it is 351. The boiling point of ethanol is 351 Kelvin. The boiling point of methoxymethane is 248 Kelvin. Almost all 100 degrees centigrade more than that of methoxymethane. And propane, comparable molecular mass, it is 44. Its boiling point is 231. Therefore, ethanol boiling point is almost all 100 degree more than that of propane as well as methoxymethane, although they have same molecular mass as well as comparable molecular mass. This is due to the presence of intermolecular hydrogen bonding. Therefore, my dear student, in your board exam as well as in competitive exam, if they ask what is the reason for the alcohols having high boiling point, please select that answer. This is due to the presence of intermolecular hydrogen bonding. As you know, what is hydrogen bonding? Hydrogen bonding means it's a bond which is formed between hydrogen and more electronegative atoms like oxygen, nitrogen and halogen. In hydrogen bonding, we have intramolecular hydrogen bonding and intermolecular hydrogen bonding. Alcohols have intermolecular hydrogen bonding. Because of that intermolecular hydrogen bonding, they have high boiling point than that of hydrocarbons, ethers, haloalkanes and haloarenes having comparable molecular mass. That I can explain by taking three compounds like one in alcohol, ethanol, second one in ether, methoxymethane, third one in hydrocarbon, that is propane. Okay. Next, solubility. Solubility of alcohol in water is due to the ability to form hydrogen bonds with water molecule. Solubility decreases as increase in the size of alkyl group, Why? As the size of alkyl group increases, the solubility decreases. The alkyl groups are hydrophobic in nature. What's the meaning of hydrophobic? Hydrophobic means those hates water, that nature is called as hydrophobic. Therefore, alkyl groups are hydrophobic in nature. As the size of alkyl group increases, the solubility decreases. For example, when you consider methanol, ethanol, propanol, butanol is less soluble because the size of the alkyl group is more. Therefore, in case of solubility, decreases with increase in size of the hydrophobic group. This is about the physical properties of alcohol. Under that physical property, I discussed about boiling point as well as solubility. Boiling point of alcohol is high because due to the presence of intermolecular hydrogen bonding. Because of this hydrogen bonding only, alcohols are soluble in water. Next, let us consider chemical properties. The chemical properties of alcohol can be classified into two types. First one, when I consider this as a structure of COH, this is HH. When I consider methanol, so the reactions of alcohols are classified into two types. One is cleavage of OH bond, another one is cleavage of CO bond. So the reactions involving cleavage of oxygen hydrogen bond, reaction involving cleavage of carbon oxygen bond. This is oxygen hydrogen bond. This is carbon oxygen bond. Therefore, the reactions of alcohols are classified into how many types? Two types. Reactions due to the cleavage of OH bond and reactions due to the cleavage of CO bond. Reactions due to the cleavage of OH bond and reactions due to the cleavage of CO bond. First one, reactions involving cleavage of OH bond. Reactions involving cleavage of OH bond. In that, I will consider acidity of alcohol. Alcohols are acidic in nature. How can we say alcohols are acidic in nature? For that, treat alcohol with more electropositive or highly electropositive metals like sodium, potassium, aluminium. Sodium, potassium, aluminium. They reacts with sodium, potassium, aluminium. They liberates hydrogen along with formation of alkoxide. For example, when you consider the general formula of alcohol is ROH, the H of alcohol is replaced by Na and it will form RONA, that is sodium alkoxide, along with liberates hydrogen. When hydrogen is liberated, already you know that when metals liberates hydrogen, when they reacts with acid. Therefore, alcohols are acidic in nature. How can you say alcohols are acidic in nature? When alcohols are heated with or treated with highly electropositive metals like sodium, potassium and aluminium, they liberates hydrogen along with formation of sodium alkoxide. This reaction shows that alcohol is an acidic in nature. When you treat tertiary butyl alcohol with aluminium, it will form aluminium tertiary butoxide with the liberation of 3 moles of hydrogen. This reaction shows that alcohols are acidic in nature. The above reaction shows that alcohols are acidic in nature. In fact, alcohols are Bronsted acid, that is, they can donate a proton. You know that what are Bronsted acid? Bronsted acids are the acids which donates proton. When you observe this as a base and alcohol, it donates proton, base become BH and it will become RO minus. RO minus is called as alkoxide ion. Therefore, alcohol is act as Bronsted base because it is a proton donor. Okay, the acidic nature of alcohol is due to the presence of polar OH group. So, as you know, in substituents, we have 2 types of substituent, electron withdrawing groups as well as electron donating group. Alkyl groups are electron donating. As alkyl groups donates electron, the electron density, for example, this is a general formula of alcohol. Already oxygen has 2 lone pair of electron. R is electron donating group, means it starts to donate electron to oxygen. Therefore, electron density increases. Electron density on oxygen increases, which decreases the polarity of the OH group. As electron density increases, the polarity of the OH group decreases, the stability is decreases, as well as acidic strength also decreases. As the alcohol contain more number of alkyl group, it is less acidic. As the number of alkyl group increases, acidity decreases, because alkyl is an example for electron donating group because of positive inductive effect. When it donates electron, the density on oxygen atom increases. As density increases, the polarity decreases. Stability decreases due to positive inductive effect. This decreases the acidic strength of alcohol. When you consider primary alcohol, it has only 1 alkyl. Secondary, it has 2 alkyl. Tertiary, it has what? 3 alkyl. Therefore, which one is less acidic? Tertiary is less acidic than secondary and secondary is less acidic than primary. Why primary alcohol is more acidic among secondary as well as tertiary? Because it contains only 1 alkyl group. Next secondary, it has 2 alkyl, tertiary 3 alkyl. Already, please, my dear student, note this. When alcohol is attached with more number of alkyl group, its acidic strength decreases. Why when it is attached with more number of alkyl group, its acidity decreases? Because alkyl group is electron donating group because of positive inductive effect. As it donates electron, the density of on oxygen atom of OH group increases. Therefore, polarity decreases, stability decreases, acidity decreases. Polarity decreases, stability decreases, as well as acidity decreases. Therefore, primary alcohol is more acidic than secondary. Secondary is more acidic than tertiary. In alcohols, the electron donating nature of alkyl group, the stability of alkoxide ion decreases. But in the case of water, OH minus formed by ionization more stable than alkoxide ion due to the absence of electron donating group. When I am comparing with water, water ionizes as H plus and OH minus. Ethanol, when you consider alcohol, it ionizes as H plus and CH3, CH2, O minus. In water, there is an absence of electron donating group. Therefore, alcohols are weaker acid than water. Alcohols are weaker acid than water. Next, esterification of alcohol. What is esterification? Alcohols are converted into esters. We want to convert alcohol into ester. How do you convert alcohol into ester? Alcohol can be converted into ester by two reactions. One is esterification, second one is acylation or acetylation. So, second one, how do you convert alcohol into ester? The functional group alcohol is OH. The functional group of ester is COOR. Functional group of alcohol is OH. The functional group of ester is COR. How do you convert alcohol into esters? Alcohol can be converted into ester either by esterification or by acylation or acetylation. Therefore, there are two methods of conversion of alcohols into ester, either by esterification or by acylation or acetylation. First one, esterification. Esters are produced when alcohols are heated with carboxylic acid. How can you produce esters? Esters are prepared by heating alcohol with carboxylic acid. When alcohol is heated with carboxylic acid in the presence of acid catalyst, acid can be used concentrated sulfuric acid, or one we can use dry HCl. What's the role of concentrated sulfuric acid or dry HCl in esterification? They act as dehydrating agent, or they act as protonating agent, Therefore, what is esterification? When an alcohol is heated with carboxylic acid, in the presence of concentrated sulfuric acid or dry HCl, they'll form ester and water. This reaction is called as esterification. What's the role of concentrated sulfuric acid or dry HCl? Concentrated sulfuric acid or dry HCl, they act as dehydrating agent or protonating agent. The reaction is reversible. Equilibrium can be shifted towards the forward direction by removing the water as soon as it is formed. The general formula of acid is RC double bond OH. General formula of alcohol is R-OH. From acid remove OH, from alcohol remove H. There is a formation of water and ester RC double bond O-R'. Therefore, what are the reactants required to prepare ester? One is alcohol, another one is carboxylic acid in the presence of concentrated sulfuric acid or dry HCl. What's the role of concentrated sulfuric acid or dry HCl? It acts as dehydrating agent or protonating agent. For example, you take acetic acid and methyl alcohol, you will get methyl acetate. You take acetic acid and ethyl alcohol, you will get ethyl acetate. You take benzoic acid and ethanol, you will get ethyl benzoate. From acid you remove OH. From alcohol you remove H. Methanol is CH3OH, ethanol is CH3CH2OH. Here you remove H, there is a formation of water. Rest of the thing you join. CH3C double bond O, OCH3, this is methyl acetate. CH3C double bond O, CH2CH3, it is ethyl acetate. Benzene ring with C double bond O, CH2CH3, it is ethyl benzoate. Okay. Next, the second method of preparation of ester is acylation or acetylation. What is acylation or acetylation? Introduction of acyl group is called as acylation or acetylation. This can be done by heating with acid chloride, or by heating with acid anhydride, So, esters can also be obtained by treating alcohol with acid chloride or acid anhydride. The reaction with acid chloride is done in the presence of pyridine to neutralize HCl. To neutralize HCl, what we had to add? We had to add pyridine. The introduction of acetyl group in alcohol is known as acetylation. ROH plus R-OCl. ROH is the general formula of alcohol. R-COCl is the general formula of acid chloride. From alcohol you remove H. From acid chloride you remove Cl. It will form HCl. Remaining is RCOO, R'. Take methyl alcohol. methyl alcohol, remove HCl, and acid acetyl chloride, here you remove Cl, it will form HCl, remaining is CH3COO, CH3. In ethanol, remove H, here you remove Cl, there is a formation of HCl, remaining is C2H5COO, CH3. You have to use pyridine. This pyridine is neutralize what? HCl. So, therefore, we have two methods of preparation of esters from alcohol. One is esterification and second one is acylation or what? Acetylation. Next, fourth reaction is oxidation. Oxidation of alcohol involves the breaking of formation of carbon-oxygen double bond, carbon-oxygen of double bond by breaking of OH bond and CH bond. There is a, when during oxidation, there is a breakage of OH bond as well as CH bond. Carbon-oxygen single bond becomes carbon-oxygen double bond. This reaction is also called as dehydrogenation because there is an elimination of hydrogen. Therefore, oxidation of alcohol is also called as dehydrogenation. During oxidation, what happens? There is a breaking of OH bond as well as CH bond. When OH bond is broken, so one H is formed. So, one atom of hydrogen, here also one atom of hydrogen, both combine to form hydrogen. Therefore, the oxidation reaction of alcohol is also called as dehydrogenation. In oxidation, I will consider three cases: primary alcohol, secondary alcohol as well as tertiary alcohol. Case 1, primary alcohol. Primary alcohol undergo oxidation in the presence of strong oxidizing agent like acidified potassium dichromate or acidified potassium permanganate. Acidified potassium dichromate and acidified potassium dichromate. Primary alcohol. What's the general formula of primary alcohol? RCH2OH. When they are heated with oxidizing agent, acidified potassium dichromate or potassium permanganate, acidified potassium dichromate or acidified potassium dichromate, first they get oxidized to aldehyde, then it get oxidized to carboxylic acid. Therefore, primary alcohols are easily oxidized to aldehyde, then to carboxylic acid in the presence of strong oxidizing agent like acidified potassium permanganate and acidified potassium dichromate. Oxidation of the same primary alcohol, if you want to stop at aldehyde stage, as you know, primary alcohol in the presence of strong oxidizing agent, as you know, primary alcohols in the presence of strong oxidizing agent like acidified potassium dichromate or acidified potassium permanganate, first it get oxidized to aldehyde, then it is oxidized to carboxylic acid. If you want to stop at aldehyde stage, instead of strong oxidizing agent, one you can use mild oxidizing agent such as pyridinium chlorochromate. Mild oxidizing agent like pyridinium chlorochromate, PCC. P stands for pyridinium, C stands for chloro, C stands for chromate. So, it is a complex of chromium trioxide with pyridine and HCl. How can you prepare pyridinium chlorochromate? Pyridinium chlorochromate is obtained by mixing pyridine with chromium trioxide and HCl, and it's a very beautiful example for mild oxidizing agent. Therefore, same primary alcohol, if you use strong oxidizing agent, first it get oxidized to aldehyde, then it get oxidized to carboxylic acid. Instead of strong oxidizing agent, if you use mild oxidizing agent like pyridinium chlorochromate, or it is also called as PCC, the oxidation stops at aldehyde stage only. So, when you consider any primary alcohol, observe here, round off this primary alcoholic functional group CH2OH and you convert into CHO. The rest of the part remain as it is, that is hydrocarbon part remain as it is, only there is a change in the functional group. Primary alcoholic group is converted into aldehyde group in the presence of mild oxidizing agent like PCC. When you use a strong oxidizing agent, this aldehyde further get oxidized to carboxylic acid. Next, now I'll consider oxidation of secondary alcohols. Secondary alcohols are oxidized to ketones by chromic anhydride or chromium trioxide. The general formula of secondary alcohol is RCHOH R-. In the presence of chromic trioxide or chromic anhydride, it get oxidized to ketone or C double bond O R-. For example, when I'll consider secondary alcohol, isopropyl alcohol CH3CHOH in the presence of chromic anhydride, it get oxidized to acetone. So the secondary, here also round of secondary alcoholic functional group was the primary alcoholic functional group is CH2OH, secondary alcoholic functional group is CHOH, tertiary alcoholic group is COH. Now round off secondary alcoholic functional group and you convert into ketone functional group. The hydrocarbon part remains as it is. Observe here, CH3 remain as it is. Only the secondary alcoholic functional group is converted into ketone. In case of primary alcohol, the oxidizing agent used is acidified potassium dichromate or acidified potassium permanganate. In case of secondary alcohol, one you can use chromic anhydride or chromium trioxide. Now the ketone which is formed, which is under further oxidation under drastic condition, the ketone functional group is converted into carboxylic acid, as well as it forms carboxylic acid which containing less number of carbon atom as that of ketone. That means when ketones are converted into carboxylic acid, the number of carbon atoms present in carboxylic acid less than that of the ketone. For example, observe here, in acetone, how many carbon atoms are there? 3. 1, 2, 3. But in case of acetic acid, we have only 2 carbon atom. Therefore, the carboxylic acid form which containing less number of carbon atom as that of ketone. Finally, we'll consider tertiary alcohol. Primary alcohols and secondary alcohols undergo oxidation very easily, but tertiary alcohol do not undergo oxidation reaction easily. Under drastic conditions, in the presence of strong oxidizing agent, as well as at elevated temperature, the cleavage of carbon-carbon single bond takes place and it will form mixture of carboxylic acid containing lesser number of carbon atoms. Okay, therefore tertiary alcohols does not undergo oxidation very easily under drastic condition and in the presence of strong oxidizing agent, as well as in the elevated temperature. Under drastic conditions, strong oxidizing agent like KMNO4 at elevated temperature, cleavage of CC bond takes place and a mixture of carboxylic acid containing lesser number of carbon atom. The general formula of tertiary alcohol, C is attached with 3 alkyl group OH. Oxidation under drastic condition, first it gives rise to ketone, then it gives rise to mixture of carboxylic acid which containing less number of carbon atom as that of tertiary alcohol. Example, tertiary butyl alcohol. C, how many CH3 groups are attached? 3 CH3 groups are attached, OH, which on oxidation under drastic condition and in the presence of strong oxidizing agent potassium permanganate, first it get oxidized to acetone, then it get oxidized to acetic acid. Therefore, out of these 3 alcohols, the tertiary alcohol oxidation does not undergo very easily. My dear student, in the next session, I am going to take up the reaction which are involving cleavage of carbon-oxygen bond. In the previous sessions, I did reaction due to the cleavage of OH bond. In the next session, I am going to deal with reactions of alcohol due to the cleavage of CO bond. Okay. So, my dear student, next session, I will come up with reaction involving cleavage of CO bond. Until that, goodbye, take care, thank you.